Good evening, cadets. I am AU Osha and I'll be your instructor this evening. Bearings. What is a bearing? A bearing is direction in degrees from a reference point. Now, there are three reference points, split in two, should I say. But these three reference points basically delves into our types of bearings, of which we have three types of bearings. We have grid bearings, true bearings, and magnetic bearings. These three types of bearings corresponds to three types of norths. We have grid north, true north, and magnetic north. I would have given the norths after the bearings, but in truth is the reverse. The north actually precedes the bearings. So it's grid north corresponds to grid bearings. True north corresponds to true bearings. Magnetic north corresponds to magnetic bearings. I will give a formal definition of of these norths and bearings, and just say that you need to know it because you just need to know it. And I will then explain how it will apply to the field and future lessons. So, formal definitions, starting with grid north. Grid north is the direction of the vertical lines on a map. True north is the geographical North Pole, the point on the Earth's surface where all longitude lines converge. Magnetic north is the direction of the Earth's magnetic pole, which is constantly shifting point in the Arctic region. Grid bearing is the horizontal angle measured clockwise from grid north to a specific point or direction. True bearing is the horizontal angle measured clockwise from true north to a specific point or direction. Magnetic bearing is the horizontal angle measured clockwise from magnetic north to a specific point or direction. How these things, the knowledge of these three relate to the JCCF and you in the field is that in the field you'll be using a map, of course. You'll be using a protractor, maybe more or less, depends. But most commonly, you'll be using a compass. So there are three things you're likely to be using in the field. Definitely going to be using a map, most commonly a compass, and maybe a protractor, maybe. These three items correspond to the types of north and the types of bearings. Specifically, if when it comes on to the compass, you're using the map combined with compass, you're actually utilizing whatever direction you're finding in the degrees from using that reference point will actually be magnetic bearings. So once you're using that map with the compass, what you're finding is magnetic bearings. And if this is of course relative to the magnetic north. When you're using the map alongside the protractor, whatever direction you're finding will actually be grid bearings relative to the magnetic north. True bearings, which is the most accurate bearing because it's relative to true north, which is the Earth's rotational axis, which is fixed. So that makes true bearings the most accurate of all bearings. You won't be using in the field. That's more so aviation. So if there's aviation as a path, that's where you'll likely encounter true bearings. But for the field, it will be magnetic bearings and grid bearings. And grid bearings usually if you're using the protractor versus if you're using the compass, you're going to be finding magnetic bearings. And so that's how it's going to be important in the future in the field. So for the purpose of the JCCF, you're really only focusing on two, magnetic bearing and grid bearings. And that's where the knowledge is important. So you just need to know all of this because it's going to be valuable in the future. So you know that, okay, I found a direction on the compass, really using the map and the compass. What I'm actually finding is the magnetic bearing, and that is relative to the magnetic north.